So, hi everyone. Today's topic is about architectural styles. An architectural style is a transformation that is imposed on the design of an entire system. The intent is to establish a structure for all components of the system. In the case where an existing architecture is to be re engineered, the imposition of an architectural style will result in fundamental changes to the structure of the software, including a reassignment of the functionality of components. An architectural pattern, like an architectural style, imposes a transformation on the design of an architecture. However, a pattern differs from a style in a number of fundamental ways. The scope of a pattern is less broad, focusing on an aspect of the architecture rather than the architecture in its entirety. There are different types of architecture styles are in this. The first one is pipes and filters. A pipe and filter pattern has a set of components called filters connected by pipe that transmit data from one component to the next. Each filter works independently of those components upstream and downstream. It's designed to expect data input of a certain form and produces data output of a specified form. However, the filter does not require knowledge of the workings of its neighboring filters. If the data flow degenerates it into a single line of transforms, it is termed a batch sequential. The structure accepts a batch of data and then applies a series of sequential components to transform it. The diagrammatic representation of pipes and filters. Pipes are used for transforming data from one component to the another, and the filters are used for transmitting data independently from one component to another components. And the next one is call and return system. This architectural style enables you to achieve a program structure that is relatively easy to modify and scale. A number of substyles exist within this category. Main program or subprogram architectures. This classic program structure decomposes function into a control hierarchy, where a main program invokes a number of program components that in turn may invoke still other components. Remote procedure call architectures. The components of a main program or subprogram architecture are distributed across multiple computers on a network. The diagrammatic show of call and return system. The first main program is divided into controller subprograms, and the controller subprograms are subdivided into application subprograms. These are the branch representation of the system. And the next one is object oriented system. The components of a system encapsulate data and the operations that must be applied to manipulate the data. Communication and coordination between components are accomplished via message passing. Characteristics. Objects protect the system's integrity. An object is unaware of the depiction of other items. Advantages of object oriented architecture. It enables the designer to separate a challenge into a collection of autonomous objects. Other objects are aware of the implementation details of the object, allowing changes to be made without having an impact of other objects. And the next one is layered system. The basic structure of layered architecture is illustrated. The number of different layers are defined, each accomplishing operations that progressively become closer to the machine instruction set. At the outer layer, components service user interface operations. At the inner layer, components perform operating system interfacing. Intermediate layers provide utility services and application software functions. These architectural styles are only a small subset of those available. Once requirements engineering uncovers the characteristics and constraints of the system to be built, the architectural style and our combination of patterns that best fits those characteristics and constraints can be chosen. In many cases, more than one pattern might be appropriate and alternative architectural styles can be designed and evaluated. For example, a layered system can be combined with a data centered architecture in many database applications. The diagrammatic view. The core layer is the inner layer of this layered system. And the next one is utility layer, and the next layer is application layer, and the outer layer is the user interface layer, which makes an interaction between the application layer and the utility layer. It transforms data from user interface layer to the core layer through the intermediary forms. And the next one is data centered system. Data, which means a file or a database store, resides at the center of this architecture and is accessed frequently by other components that update, delete, or add or otherwise modify data within the store. Client software acts as a central repository. In some cases, the data repository is passive. That is, client software accesses the data independent of any changes to the data or the actions of other client software. A variation on this approach transforms the repository into a blackboard that sends notifications to client software when data is interest to the client challenges. Data centered architectures promote integrability. That is, existing components can be changed and new client components are added to the architecture without concern about other clients. In addition, data can be paused among clients using the blackboard mechanisms. Client components independently execute process. The diagrammatic view. The data bases are placed at the center of the software. Because through this, the client software can easily fetch their data or information, whatever they need. They can be easily fetched through the center of the database. So the next topic is about how to measure the goodness of the design. To measure the goodness of a software design, it's crucial to evaluate coupling, how interconnected different modules are, and the cohesion, how closely related elements within a module are. High cohesion and low coupling are generally desirable for a well-designed system. First one is coupling. Coupling refers to the degree of interdependence between different modules or components in a system. Lower coupling is generally better as it indicates that modules are more independent and can be modified or replaced without affecting other parts of the system. Coupling between two modules is the strength of interconnections between modules or a measure of interdependence among modules. Coupling depends on the interface complexity between modules, the point at which entry or reference is made to a module, and what data pass across the interface. Highly coupled modules are joined by strong interconnections, while loosely coupled modules have weak interconnections. The types of coupling: data coupling, stamp coupling, control coupling, external coupling, common coupling, and content coupling. The first one is content coupling. Content coupling occurs when one module modifies local database or instructions in another module. The content coupling can occur in assembly language or programs. Content coupling occurs when branches are made into the middle of the module. It is the highest degree of coupling, and this mode of coupling can and should be avoided. Common coupling. In common coupling, modules are bound together by global data structures. While common coupling, it can be difficult to determine which component is responsible for having a set of variable for a particular value. For example, Fortran program refers to a single common data block. And the next one is control coupling. When a one component passes parameters to control the activity of another component, we say that there is control coupling between the two. In a design with control coupling, there is an advantage to having each component perform only one function or execute one process. It involves passing of control flags such as parameters or global between two modules. Stamp coupling. Stamp coupling is similar to common coupling except that global data items are shared selectively among routines that requires the data. Stamp coupling is more desirable than common coupling because FIBR modules will have to be modified if a shared data structure is modified. And the last one is data coupling. Data coupling involves the use of parameter test to pass data items between routines. Data coupling is simpler and leaves less room for error. If coupling must exist between components, data coupling is the most desirable. It is the easiest to through which to trace data and to make changes. This is how the software designs can be measured through coupling format. And the next one is cohesion. Cohesion is a measure of the degree to which the elements of the module are functionally related. It is the degree to which elements directed towards performing a single task are contained in the component. Basically, cohesion is the internal glue that keeps the module together. A good software design will have high cohesion. The types of cohesion: function, sequence, communicational, procedural, temporal, and logical and coincidental. Cohesion refers to the degree to which elements within the model work together to fulfill a single well defined process. The first one is coincidental cohesion. Coincidental cohesion occurs when the elements within a module have no apparent relationship to one another. It occurs when an existing program is modularized into pieces and making different pieces of modules. If a module is created to save duplicate code by combining some part of the code that occurs at many different places, that modules are likely to have coincidental cohesion. At the lower end of the spectrum, we encountered a model that performs a set of tasks that relate to each other loosely. Such modules are termed as coincidentally coherent. Logical cohesion. A module have logical cohesion if there is some logical relationship between the elements of the module and the elements perform functions that fall in the some logical classes. For example, one component may read all kind of inputs from tape, disk and telecommunication ports regardless of where the input is coming from or how it will be used. And the next one is temporal cohesion. Temporal cohesion is the same as logical cohesion, except that the elements are also related in the time and are executed together. Models that perform activities like initialization, which have to initialize the process, cleanup, which is used to clean the process, and termination, which means looping the process which from starts to end it will terminate up to the conditions will be failed are usually temporally bound. Modules with temporal cohesion exhibit many of the some disadvantages as logically bound modules. However, they are higher on the scale of binding because all elements are executed at one time and no parameters or logic are required to determine which elements to execute. And the next one is procedural cohesion. The procedural cohesion module contains elements that belong to a common procedural unit. For example, a loop or a sequence of decision statements in a module may be combined to form a separate module. Procedural cohesion often cuts across functional lines. A module with only procedural cohesions may contain only part of the complete function or parts of several functions. And the next one is communicational cohesion. A module with communicational cohesion has elements that are related by a reference to the same input or output data. For example, print and punch the output file. It is a communicationally bound. Yes, communicational binding is higher on the binding scale than temporal binding because the elements are executed at one time and also refers to the same data. And the next one is sequential cohesion. Sequential cohesion of elements occurs when the output of one element is the input for the next element. For example, read next transaction and update master file. It is sequentially bound because sequential cohesion is high on the binding scale and the modular structure usually bears a close resemblance to the problem structure. The last one is functional cohesion. Functional cohesion is the strongest cohesion. In a functionally bound module, all the elements of the module are related to performing a single function. For example, a functionally bound modules are compute square root and obtain random number. In modules with a functional cohesion can always be described by a simple structure, but sometimes it can also be described using compound structures. So this is how cohesion is used for measure the goodness of the software design. Thank you.